Hi, my name is Susan Yee. Today I'm going to present for my final year project, which is the title of AI-based VCRP Violations Waiver Application System. For my project, I'm under two supervisors. One is from UTM, which is Dr. Afzan, and the second is from Intel, which is Mr. Yo Chunzhen. For my project, it is focused on the static low power design, where the violations flagged by the VCRP2, some are expected to be waived permanently or temporarily. And previously, all the reviews and waivers applied to the violations are done manually by the engineers in Intel, which is inefficient, time-consuming, and error-prone. That's why we came out with this project in order to utilize AI to automate waiver generation for static low power violations. For the motivation behind the project, the first is all the violation reviews and waivers application are done manually until now, which are inefficient and time-consuming. And second is the comments written for the waivers are not standardized, as each of the users or each of the engineer has their own writing style, so it might confuse the users when they want to review the comments or the waivers written by the others engineers. For the first objective of my project is to generate waivers for static low power violations with the correct permanent or temporary tag. And the second objective is to use the intended waiver fields based on the violation error type or tag. And the last one is to propose the global waiver candidate for the violation with the high occurrence across the different blocks. Now I'll be explaining the mechanism of my AI model. The most important thing in the model is the LM, where we are using the ChatGPT 3.5 Turbo API offered from Also AI by Intel. And I'm using the LangChain to link the tool's design as well as the prompt script written by me together with the LM. So what does the whole mechanism is? The first thing, the user will provide the violation to the LM. And from there, the LM will go through the self-written prompt script by me with the natural language. And by using the LangChain, it will be able to go through the prompt, the instruction written based on the violation. And from there, the LM will go through the step-by-step instructions and to check whether the violation is able to waive permanently or temporarily. And the instruction as well, it will ask the LM to open the certain reports or certain files to check whether the violation is expected to be waived temporarily or permanently. And from there, if the instruction is asking the LM to call the tools, and by using LangChain, it will link the tools, which is written by me as well using the Python programming language, to conduct the checking whether the violation is permanently waived or temporarily waived. Now, I'll be using an example to explain the overall mechanism of my AI model. So the first thing first is the user have to provide the violation information to the LM, as shown as here. From the violation tag provided by the user, the LM will go through the violation specific based prompt instructions to do the checking whether the violations should be temporarily waived or permanently waived. And by using LangChain, it will link the tool calling together with the prompt instruction. So let's say the prompt instruction is asking the LM to call the tool to conduct the further checking. The LM will proceed to call the tool by using LangChain and conduct the further checking. And lastly, after conducting all the checkings from the instructions, it will proceed to generate the waiver as shown as here. Now I'll be explaining the flows to execute the AI model. So for the first step, the user have to set up the terminal with virtual environment as shown as the steps here. And then it needs to provide the violation information as shown as here in a particular .text file. So that after that, the LM will go to the text file and grab the specific information needed for the checking. And then the user should execute this command in order to run the AI model. There's two important input here. The first is the dash input. For this one, it's just the text file that the user have been declared in the second step. And for the dash details, it should be put in false if the user doesn't want to have a clearer details information explaining for each of the steps conducted. If the user wants to have a clearer understanding of the details of the instruction conducted, then they should put true for the dash details. After conducting the checking, the AI model will proceed to print out the waiver as shown as here to the terminal. So either with permanently tag or temporarily tag. These are some of the examples that I've been testing for my AI model. So when I've been pasting the violation as shown as here, that I'll be expecting a permanently waive, and the AI model is able to generate the permanently waiver. This is another permanently waive example, and the AI model is also able to generate the correct permanently waive waiver. This is the example for temporary waive. So when I'm pasting the information of the violation that expecting a temporary waiver generated, the model is also able to generate the correct temporary waiver. This is also another temporary waiver example. As shown as here, the model is also able to generate the correct temporary waiver. For my project, I'm contributing to the SDG 9, which is the Industry, Innovation and Infrastructure. So the reasons are, I'm promoting innovation in semiconductor industry. My project is able to introduce an AI power automation into a highly manual domain waiver generation in static low power design. This is able to enhance productivity and also reduce manual engineering effort. Second is to build a smart digital infrastructure. My system is able to act like a digital assistant where will be reduce the need for manual waiver entry and decision making. And the third one is I'm able to encourage efficient industrial process where I'm able to automate repetitive tasks, speed up the design verification process, and also reduce the risk of human error. Lastly, which is the scalable and sustainable innovation, my AI model is able to reduce the engineering costs and minimize energy usage in long training cycles. This is because for LangChain, there's no fine tuning needed for the model to do the specific task. So for the commercialization potential for my project, the first is industry demand. I'll be applying my AI model in Intel in order to automate the waiver generation, saving engineer time, and also reduce the verification bottlenecks. And second is to integration with existing workflows, as my project is designed based on the available working models available in Intel. So this is able to easy to adopt within the existing engineering environments without the needing of major infrastructure changes. And lastly is the cost saving and return on investment, as my project is able to automate the waiver generation, which greatly reduce the manual effort, cuts turnaround time, and avoids mistakes that lead to design delays. And all of the advantages that I've listed down is able to translate to huge saving in engineering man hours, KPI cycles, as well as time to market. And that's all from me. Thank you.